Okay, so this is going to be a quick video covering factor and remainder theorem. So this is basically a theorem made by this French mathematician, Etienne Bezout, I think his name was. I may have butchered the name, but the factor and remainder theorem, what it basically states, let's read the definition together. If a polynomial f of x is divided by x minus a, the remainder is f a. You can disregard this, we don't need that. We don't need this entire statement. Just look at the first sentence. So let's analyze what it basically means. So if a polynomial f of x can be any polynomial, like for example x squared plus 2x plus 3, right? And they say it is divided by x minus a, and a can also be any number. It can say, for example, be x minus 2, right? X minus 2, x minus 3, x minus 4. So if it is divided by this equation, like x minus a, the remainder is equal to f of a. Now, what does f of a mean? So, you know how functions work. I'm going to quickly explain how functions work. So, take functions as a sort of machine. And machines, basically, what they do is they take inputs, and they give outputs. Now, inputs are the thing you put here. This is where you put the input. And whatever it's equal to is the output. So I'm going to be using this term a lot, so just memorize this again. Whatever you put here is the input, and whatever that equates to is the output. And, okay, so f of x. Let's just erase that. So I hope you understood. Now let's move on to f of x. So x minus 2. How do we get the value of a? Like, how do we figure out we have to use exactly a and not minus a? Well, the procedure for that is equating this to 0 and then finding the value of x. This is what we're going to be using as our input. You can look over here, it says x minus a, and the remainder is f of a. Well, x minus a is equal to 0, x is equal to a. That's how we know we're using positive a and not negative a. For example, if we're dividing it by x plus 2 instead of x minus 2, we'll actually have to put negative 2. We'll have to do this instead. So that's how we're able to find the input and what to put there. So f2, when you put an input of 2, you have to replace x with 2. Every instance of x you see in the equation, you have to replace it with 2. So this will be 2 squared plus 2 into 2 plus 3. So that'll be 4 plus 4 plus 3. 8 plus 3 is 11. So what I calculated means that when you divide this entire equation by x minus 2, your remainder is 11. And just to be sure, let's actually check it via synthetic division. So this is a quicker way of doing synthetic division if you're only looking for the remainder. You won't get the quotient this way. Okay, so x minus 2. I'm going to quickly solve. I think you guys should know how to do x. X. And x squared minus 2x. That'll become positive, become negative. 4x plus 3, divide that by x, that'll be x plus 4, and you should get 4x minus 4 into 2 is 8, so minus 8, and change the signs. 8 plus 3 is 11. So hence we have proved the factor and remainder theorem. We have showed that when we divide this by x minus 2, the remainder is f of 2, which is equal to 11, which we calculated. Okay, so now let's cover the factor theorem. We did the remainder theorem, now comes the factor theorem. So you guys know that when you divide something by its factor, the remainder should be 0, right? So just to confirm, say we have 6. We know that the factors of 6 are 3 and 2. So if we divide 6 by 3, the remainder should be 0. So that's what being a factor means. The remainder is 0. I covered this in my previous videos as well. Being a factor means when you divide it, you should get 0 as a remainder. So you can already see where this is heading. If the question statement says that, let's just read the definition over here. A polynomial f of x has a factor x minus a if and only if fa is equal to 0. So that says the same thing that I was saying. It says that the polynomial f of x only has a factor x minus a if f of a, basically the remainder, is equal to 0. So that was the entire factor theorem, and I'll prove it to you right now. say we have this polynomial 2x cubed plus x squared minus 7x plus 3. And let's say the factor is 2x minus 1. Okay, so the question says that this is a polynomial and this is a factor. Show using the factor theorem that this indeed is actually a factor. So first, let's find the value of a that we have to put over here. And the easiest value to find the value of a, the easiest way to find the value of a was equating the factor to 0 and then finding the value of x. So 2x is equal to 1, x is equal to 1 by 2. So now, that basically means, since it's a factor, that means that f, and this is equal to, this is fx by the way. So basically that means f 1 by 2 is equal to 0. Let's show that. So f 1 by 2 is equal to 2, 1 by 2 cube plus 1 by 2 square plus, minus. Okay, so that'll be 2 over 8 plus 1 by 4 minus 7 by 2 plus 3 and 2 by so this is all equal to such 2. Actually, I'll solve it part by part. So 2 by 8 plus 1 by 4 is equal to 1 by 2 minus 7 by 2 plus 3. So that is 1 minus 7 is negative 6. So negative 6 divided by 2 plus 3, which is negative 3 plus 3, which is 0. So therefore we have proved that 2x minus 1 is a factor of f of x.